Alright, good morning chemistry. Today we're going to be learning about enthalpy as part of section 9.3. So, enthalpy is a way of measuring energy transfer. This whole chapter is about energy, heat, and how we can measure that in reactions. So, one of the ways we measure that is enthalpy. A couple of things before we get started. So substances have a designated amount of internal energy. That energy can be chemical bonds, it can be in the way the molecules move, but there is an internal energy of molecules, and that internal energy is designated as U. All right. So U is going to be the internal energy for any given substance. Now, when things undergo a chemical reaction, when substances undergo a chemical reaction, or even a physical change, like from solid to liquid or liquid to gas, there is a change in the internal energy, in the U. And then the two things that can make the U change, that can make the internal energy change, are either going to be work or heat or work. So any change in these two things, either heat or work, is going to cause a change in internal energy. Now, you might be thinking, okay, I understand a change in heat, but what's a change in work look like? Well, that can be bending a metal rod, any sort of change in pressure, or the volume of the container that something's in. Right? Basically, any sort of movement does not involve heat or temperature. Right? So that's going to equal your change in internal energy. One type of work is expansion work. Right? And expansion work is going to be anything that has to do with the container. So a change in pressure, let's say the chemical reaction builds up a lot of gas, that gas expands and it puts up pressure on its container, or a change in the volume of the container, that's going to be some sort of expansion work. It's causing an expansion of the surroundings or of the container. All right. So then we have the measure of enthalpy. So enthalpy, you might have heard it explained as a measure of disorder or a measure of chaos. We're going to use the letter H, capital H, to abbreviate enthalpy. And enthalpy, mathematically, is going to equal the sum of the internal energy and the product of the pressure and the volume. So remember this expansion work deal, it has to do with pressure and volume and any changes therein. That combined with the internal energy, which is going to be the sum of the heat and the work, is going to equal the enthalpy. All right, so it's this kind of all-in-one measurement for any sort of change in the substance. All right, so any change in enthalpy, delta H, is going to equal the change in the internal energy, so Q plus W, plus the product of pressure and volume. Right? So, in order for this thing to be true, though, we have to have a constant pressure. So that's an important thing to note, is that this only happens at constant pressure. Right. At any sort of change in pressure is going to affect our change in U or change in volume. So this has to be at a constant pressure, whatever that may be, in order for us to measure the proper change in enthalpy. Otherwise, this equation doesn't work. Right? So Another thing, I won't show you how this is derived, but the change in enthalpy is effectively going to measure the heat given off by an equation. So change in H is going to equal a Q. Now this isn't necessarily the same as this Q. Technically it's Q sub P. But this assumption works at constant pressure. And what it basically means is that we can measure the change in enthalpy by measuring the heat given off or taken from any given reaction. So this is going to be a very useful observation for our next problem. All right, now in our next problem, this is going to be example 9.8. All right, we have a couple things going on. We have 0.05 moles of HCl, same thing of NaOH, and they produce the same amount of NaCl. So we have 0.05 moles of hydrochloric acid plus 0.5 moles of NaOH, and that yields 0.05 moles of sodium chloride and also of water. Now what we need to do is write a equation that includes the enthalpy, or how much change and heat or chaos and disorder happens as a result of this reaction. So first thing we need to do is write the basic chemical reaction. Also another given. We're given that the change in energy, change in E, is equal to negative 2.9 kilojoules. All right, so that's all going to be very useful. So those are our givens. Now let's get to work. First thing is going to be to write an actual equation. So we know that we have our reactants, HCl, NaOH, and that those are going to yield H2O and NaCl. All right, so we got that going on. Now, we have measurements for 0.5, so we know that 0.5 here, 0.5 here, yields 0.05 and 0.05 moles. What we need to know is how much energy is released when 1 mole of HCl reacts with 1 mole of NaOH and produces these products. So in order to find that out, we need to find out what 1 mole of HCl yields if 0.05 moles yields negative 2.9 kilojoules. All right, so look at how we set this up. We have 0.29 kilojoules, and we know that's going to be the energy release from 0.05 moles. So for every 0.05 moles we have, there's going to be 2.9 kilojoules. If we have a whole mole, then all we need to do is divide 2.9 by 0.05 to get how many kilojoules will result from a reaction with 1 mole. All right, so we divide 0.05 by by negative 2.9, and we get 58. All right, so negative 58 kilojoules is going to be released from 1 whole mole of the substance. Now, how do we write the end equation? For that, we're going to need a little bit more space. So our final equation, we want to make sure that it's balanced. We want to make sure we're including the states of matter. And we want to make sure we include the change in energy. So to start off, this is for 1 mole, so we don't have to do a coefficient in front of the reactants. So we can just do HCl. HCl is going to be in the aqueous state, plus NaOH, which is also going to be in the aqueous state. Yields, and then I'm going to just restart on this side, on the bottom. And that's going to yield a salt, NaCl, which will be aqueous, plus H2O, which will be a liquid. All right, let's make sure this is balanced. We got everything on the right side. And it looks like we're a bit short, so we need more hydrogen. We need 2. So let's go ahead and do 2 NaOH. Now that catches that up, but we have an extra oxygen. So we're going to have to add... Oh, no, wait, it was balanced because we had the H from that. Okay. So it's fine, we're balanced, we're good, and now we just add the change in enthalpy. So 1 mole of all these substances reacting is going to make a change in enthalpy of negative 58 kilojoules. All right. And so that is going to be our thermodynamics equation. We have all the reactants, we have all the products, we have the states of matter, the proper molar ratio between each reactant and product, and lastly we have the change in enthalpy. All right, so no homework for you guys today. We will be back next week. I believe it's 11 more days of school left, so hang in there. Let's finish strong, and I will see you all later.